Hey, we're going to talk about something completely different. This is like way off range. Conspiracy theories. Flat Earth. The government's taking over the world. Billionaires are in government are taking over the world. All this kind of thing. Politics. All right. Listen, both sides gaslight. They just like how one of them makes the other look horrible, and then the other makes the other look horrible. It's like maybe neither one of them are horrible, you know. um I know the severity is doesn't feel the same. Like back in, the 9/11 era, the War Powers Acts and things like that, I supported George Bush during that. You know what I mean? Of course, I would. That was like a no-brainer. It looked dangerous. They hit us, and then it was like, what are we gonna do? You know what I mean? We got to do something. So he stirred up a nest. He went and picked a fight and had those guys come out to him instead of them coming to our territory and getting us here. He figured, I'll go pick a fight there and they'll all rush out to fight us. And they did. And we, that went the way it went and everything. But the flat earthers, that one is a little weird. We live on a globe and there's a curvature, and like, if you don't understand the curvature of space time, it's like when things are in the way of each other and they both have energy, they'll push and push like this. Okay? And this is why we get spirals in everything from forces. You know, you could take a plane, a rocket, a satellite, like, there's film. Like, you can literally put a camera on a drone and send it way up in the sky and look and probably see the curvature of the earth. I don't know what. And the second part about that bugs me is, if it is a flat earth, where's the edge? How would the water not fall off? How, what is there, like a protective force by the edge that's keeping you off the edge? Um Absolutely bizarre. The third component or issue that I wanted to talk about was with space time. You have to understand, right? This is cool because this is really easy. What's so cool about space time is that down here you're breathing gas. So we're within 7 miles of weather. Up to 62 miles, you have atmosphere, and then this exosphere. It gets very thin, and it thins out and thins out and thins out as you go up, till you get to the vacuum. If you don't realize what the vacuum state is, if you need to pull a vacuum down here in order to understand it up there. But it's like no pressure. You know what I mean? There's no atoms. There's nothing pushing on you. All right, and you're also, there are fundamental forces, and then there are gauge forces. Um, I've not been to school for physics, but I know a couple things about physics. Like with physics, right? They have a few different branches. One of them is chromo, the other one is electro, and the third one is flavoro. Those three right there are what makes up your standard model. That's going to get into your quarks and your spin, and you're switching from up to down. There's a bunch of tricks to it, but it's all mass and energy converting back and forth, back and forth, back and forth, from energy to mass, energy to mass. Because if I have a big mass and I run it into another mass, or I have a proton even and I run it into another mass, and there's a collision, sometimes you can make an object, or call it a region of space-time, but like, you'll make a different kind of space. Like, you'll add mass to a mass. Like, you crash them together and they become a heavier mass for a second. You know what I mean? And they'll melt. What they do is they have, and the thing is with particle physics, there's all these different branches of it, right? Like, what I mean is, you have guys that believe in different philosophies. Like, some of them think string theory is the best. Things like that. You got loop quantum gravity. You could decide what I like thermodynamics. That's the angle that I go at it from. just to understand Einstein's relativity. That's why I do it that way, because I was a heat and air conditioning guy for a little bit, and I really get into the science of, like, you know, for instance, Freon. You know, you'll have it in a copper pipe, and you'll be boiling it, and it'll be sucking up heat and sucking up heat, and you're like, well, hold on, the temperature doesn't go up. And this thing, it's like, just keeps on taking heat, and it's changing symmetry, actually, inside, you know, from molecules, atoms, and it's breaking down, because, you know, you're superheating it, right? There are supercritical states of matter where, like, matter's trapped, and you're heating it beyond what we would call a boiling point, or you're cooling it really to absolute zero, or like a saturation point. But the basic standard model of physics is like this. If you got a sphere, right, and it's packed with a gas, let's say, maybe that gas is a molecule, you know. But if we start adding pressure for some reason, because remember, mass, like when you step in the snow, you crush through the snow, you're adding weight, right? So if this thing gets more massive, okay, and now there's more gravity, things are going to get tighter. And as that sphere gets tighter from gravity, right, you might have to change from molecules to atoms. Atoms may break open and melt and become, and hadrons might actually float around, neutrons and protons, and then they have reverse beta decay. Like, you learn about stars and learn about how in the fusion, right, in the reactor of the sun, what's going on with the nuclear properties there. Okay, like they have the Eddington limit. That tells you, like, you know, like gas pressure? Well, you can have radiation pressure. So they can fight, in a way. Radiation pressure and gas pressure are like trying to take each other's spaces. Because realize, at the end of the day, right, if you've been aware of like Feynman diagrams, Fermi-Dirac statistics, things like that, you understand that, like, these guys figured out mathematical ways of tricking matter out beyond what you and I would typically see, okay, and making it behave with properties you probably wouldn't understand. Like, for instance, time. Let's just talk about that for a second. What really even is time when you think about it, right? I mean, it's a series of actions. Like, if you take a choo-choo train 6 hours across the earth, and the earth's also spinning at the same time, as the earth is spinning and you're traveling, right, the earth is also going around the sun, and then the sun is also going around the galaxy. The last time it was on the other side of the galaxy, I mean, that was like when the dinosaurs were here. So our star booking at like 500K, you know what I mean, as the earth's just going around it, and this thing, like, it takes a couple hundred plus million years just to get from one side to the other. And as that star is making its way around the galaxy, that galaxy is booking it at 1.3 million miles an hour. So sometimes, like, a proton will come out of somewhere, like a quasar, a black hole, something that can squeeze something and fire it fast, right? And like a free proton will come in, and it'll hit the Earth, and it'll hit gas, and it'll turn into what they call a meson. And a meson, that's simple. You got muon, pion, and kaon, and they're basically like, there's a melting and a dissolving from one to the other. So they'll change from one to the other like that, and you'll end up a muon, and the muon will come in. Muons go through us all the time, like they go through your body, just like neutrinos do. Muons go through you too, and they're a little bit more harmful than neutrinos. What's weird about neutrinos is, like, they're so abundant and they come out of everything, right? And they call it like the lifeblood of the electron, because when there's changes with electrons, neutrinos come out. And it's crazy because these things, like, they come out in flood places, and then they slow down, and then they end up like stuck in the matter too. Like, there's neutrinos that are just stuck from gravity that are like kind of still. It's really weird, but you got to look up, if you want to get into stars and like reverse beta decay, electron capture, things like that. That'll teach you about like what happens when a nuclear reaction goes off, why you get photons, why you get neutrinos, all that. You know, because you're decaying, you got enough pressure that you're decaying matter. It's actually the squeezing pressure of the gravity right? That is technically enough to create this certain fluid. And this certain fluid's chemical reaction, just like a nuclear bomb, only it's really sustained from gravity. So just picture a nuclear bomb, except something that's really got pressure on the outside that's keeping it in. And now that energy inside is going to have to tunnel through the gas. So you're going to get a different product, right, when it comes through, like X-ray, things like that. But anyway, yeah, the Earth is not flat. It's a curve, and everything else in the sky is a round ball. That's the most weirdest